Lucky 13 of February codes. What have we got? Let's see. Okay, 0. You change the bubble with the one. Okay, fine. So we'll just like pass that one. It's a nice day. I got first on every problem. So this was like a sort of maze solving problem. So like we're given this maze, we start at E, and we can walk, up, right, left, down. And it costs a certain amount to walk between these platforms based on the difference between them. So like to get from S to 5 costs 6 because S is like a 0, and 0 to 5 is 5, and then it always costs 1. So it's a total of 6. This just costs 2. This costs 6. I guess this is an interesting one. You can go from 9 to 0. So 7 to 0 only costs 4, not 8. Yeah, so part A was to solve this kind of small maze. Part B, you solve a bigger maze. And then part C, you solve an even bigger maze. And I guess the twist in part C is there's many possible starting locations. Okay, so how do we do this? So this is breadth first search, a simple graph algorithm. So this is like the sort of set of places that we're exploring. And then the first thing we do is we go through the graph, and any start location, we say, okay, I can get there in 0 steps. This is how we handle multiple start locations. It's just as many locations we can get to in 0 steps. And then we do, actually, it's not BFS, I'm sorry. This is Dijkstra's algorithm, because the costs are not all, it's like it costs more than 1 unit of time to move. So we grab the cheapest thing that we know how to get to. If we've already been there, then we can ignore it and keep track of where we've been. And if it's the end, then, right, so this is how long it took to get there, and this is where. So if we got to the end, then just print out how long it took, and we're done. Otherwise, try walking up, left, right, down. So check that location. If that's a valid location, it's not a wall, then figure out how expensive it is to go there, and say, okay, now I know how to get to that location in this amount of time. And this it's true that whenever you see a location for the first time, it's always the cheapest way to get there. And the reason is that the only paths to this location that we haven't explored are things that were already more expensive. Right? If we always look at the cheapest thing every time, then we know that that was the cheapest way to get there, because any other way to get there would have used a more expensive thing. So I guess the last thing I didn't talk about is how do I compute this cost? So we figure out the value at these squares, right? It says in the problem that S and E count to 0, and otherwise we just have a number, which we, convert to a number. And then we need to figure out the cost of changing to that number. So we can either go directly, and then these are for the wraparounds from 0. So, instead of going from like 7 to 0, it's effectively going from 7 to 10. So x plus 10 minus y. And I think this one is probably not necessary. Let's see. We get the same answer? No. So it is necessary. Um, what's this case? This is the case, sure. Fine. I guess where like x is 9 and y is 0, then we can go, from basically from -1 to 0 or from 9 to 10 if you want to think about it that way. Um, sure. I guess maybe the right way to think about it is like either we can add 10 to x or we can add 10 to y. And because y is being negated here, this is like subtracting 10. Uh, yeah, that seems like a clean way to think about it. That gives us the right answer, 585. And that is it for today. See you tomorrow.